Today's lesson is 7.3, Trapezoids and Kites. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Here's a very common trapezoid that you could see. Let's go ahead and take a look at some of its parts. So the two sides of my trapezoid that are parallel, the top and the bottom in this case, are called my bases. I call them base 1 and base 2, just so that when we look at a base, when I say, hey, look at the base, we're all going to look at the same base, okay? The two sides that are not parallel, the two slanted ones, they are called the legs. And once again, I just called them leg 1 and leg 2. There is a line that goes through a trapezoid right in the center of each of the legs. This is a midpoint, and this is a midpoint, so the line is called the median. What it does is it takes the leg and it cuts it in half. Notice that this leg is different in length from this leg because this is just a normal trapezoid. And then I know that this angle plus this angle, the two angles along my leg, they add up to 180 degrees. Same thing with angle C and angle D. The two angles along my leg add up to 180 degrees. Now there is a special type of trapezoid called an isosceles trapezoid. And this is a trapezoid with congruent legs. We normally use this trapezoid because it has these 5 properties. It has exactly one pair of parallel sides, which of course are called my bases, base 1 and base 2. There is a formula for me to find the median. To find the length of this median, it is half, 1/2, times base 1 plus base 2. The legs in a isosceles trapezoid are congruent. So AB is equal to CD. And remember, since the median is right here in the middle, both parts of the legs are now equal as well. My diagonals, AC and BD, are congruent. And my base angles are congruent. So notice this angle here at A is equal to this angle here at D because they touch base 2. And angle B and angle C are equal because they touch base 1. Remember, just like in the other one, these two angles, A and B, they add up to 180 degrees because they're along the leg. So same thing with C and D. C plus D is 180 because they're along the leg. All right, let's go ahead and take a look at an example of a trapezoid. ABCD is an isosceles trapezoid, and PQ is the midsegment. Let's go ahead at first and let's find angle B. I see that I am missing one little thing that should be in my notes. Here we go. Let me add that in so that we can actually find angle B. There we go. That should have been there as 75. All right, here we go. So they want us to find angle B. They want us to find angle B. All right. So I know from my properties on the last page that angle B and angle A are equal because this is base 1. I also know that angle D and angle C are equal because they are along base 2. But that's not going to help me find angle B specifically, right? I'd want to find B specifically. I feel like I need to use that 75. I remember. Remember I told you that this angle plus this angle equals 180 because they are along the leg, right? This is my leg. And this is my other leg over here. Oops, I can't call them both leg 2, leg 1, there we go. And so since the angles are along the leg, that means that angle B plus angle C equals 180. Okay, well, you might be thinking, but that's not going to help, miss. But angle D that they gave me is equal to angle C, which I need to use. So to find angle B, I could call it X. Angle C is 75, and together they need to equal 180. So all I really have to do is subtract 75 from 180, which is 105. That's it. Since X is my angle B, I'm done. All right, the next thing I want you to do is go ahead and find PQ, which is my median. Go ahead and find PQ, which is my median. All right, let me go ahead and grab my purple because the formula from the last page said the median is equal to 1/2 times base 1. I'm just going to put a B so that I can save time, plus base 2. So my little b stands for base. I'll write that for you right here. There we go. And now I'm just going to go ahead and plug everything in. Well, the median itself would be this one right here. There's my median. So for the median, I'm going to put 5x minus 3 equals 1/2 times. Base 1 is up at the top, x minus 2, plus base 2, which is down at the bottom, 7x plus 6. There we go. I would go ahead and combine everything in the middle. Okay, I'm going to combine everything, everything inside the parentheses first because I might be able to distribute that half uh, to it and take care of it. Okay, so x plus, let me grab this just so that you can see what I'm doing. X plus 7x would give me 8x, and then minus 2 plus 6 would give me positive 4. Okay, so I just combined together my like terms, the x with the x, the numbers with the numbers. And now I can go ahead and I can distribute this half because I'm just going to take 8 and I'm going to divide it by 2, which gives me 4x. And I'm going to take 4 and I'm going to divide it by 2, which gives me 2. So I'm just cutting everything into half, okay? All right, let me copy down this side. And now I can just go ahead and I can solve my equation. And I'm going to run out of space. I can see that. So I am going to move over here. 5x minus 4x would be x minus 3 equals 2. Add the 3, x equals 5. But they wanted me to find the median, so I have to go back and I have to plug it into PQ. I have to go back and plug that into PQ. So I'm going to write, let me see, let me put it in purple. PQ equals 5 times 5 minus 3. Well, 5 times 5 is 25. 25 minus 3 would give me 22. This would be my final answer. All right. I do have a second example for you with your trapezoid. And of course, we're going to go ahead and say that this is an isosceles trapezoid. And what they've marked here are the diagonals. So I have to go back and I have to remember the property about the diagonals. I do believe that it said that AC is congruent to BD. Okay, the diagonals are congruent. So this diagonal and this diagonal, the whole things are congruent to each other. So I'm going to take a look at AC first because I put it on the left. And I'm going to say AC is the 3x part plus the 6x minus 5 part. That's going to equal, because that's what congruent means, the BD part, which would be 5x plus 2 plus 21. So I'm going to add the two pieces together. I don't know anything about the pieces. I just know that the whole thing is equal. And now I'm just going to go ahead and solve. So over here on this side, I would come, There we go. I would combine together my 3x plus 6x, which would give me 9x minus 5. And on the other side, my like terms would be the positive 2 plus the 21, which would give me 5x plus 23. And now I just have my two-step equation to solve. I'm going to go ahead and subtract the 5x because it is smaller, and I like to keep everything positive. Add my 5. Which gives me 28. I'm going to divide by 4. X equals 7. Could I go back and plug it in? Yes, I could. All right, the last quadrilateral that we are going to talk about is a kite. A kite is a quadrilateral that has two pairs of consecutive congruent sides, but the opposite sides are not congruent. This kite is a little tricky. It has three properties and three properties only. It says that two pairs of consecutive congruent sides. So this short side and this short side are equal. And consecutive means they have to share a vertex. Consecutive means they have to share a vertex. So those two are equal. And then my other two would be the longer sides. They share this vertex down here, which I know you can't see is C. Okay. The diagonals are perpendicular. Okay, so all of these are 90-degree in the center. And there is exactly one pair of opposite angles that are congruent. These opposite angles have to be in a very specific place. They are always between the two pairs of congruent sides. So it's always the angle. Notice angle D is right in between the two pairs of congruent sides. It's never this one and this one. Notice these two are different lengths from each other. Okay, the two equal ones are right here between the short side and the long side. Okay, that's it. Those are the three properties of a kite. So let's go ahead and take a look at our example. It does have two parts, but this is the last example. EFGH is a kite. The measure of angle EHG is 100 degrees. The measure of angle EFG is 40 degrees. Find the measure of angle HGF. Okay, here we go. Let's go ahead and mark this, because if we don't mark it, we won't know what we're doing. So here we go. I'm trying to remember what color I used. There we go. Okay, let me get that color. Here we go. Angle EHG. EHG. That's this one right here. 100 degrees. Okay. All right. Angle EFG. EFG. This one. 40 degrees. They're not the same, guys, so I'm not going to mark them as equal. Okay, find the measure of HGF. HGF. This is the one that they want. I'm going to put that one in a different color. Okay, now I have to stop and think for just a second. Is this angle, because this is the one they want me to find, is this angle the equal one? Because remember, there is exactly one pair of opposite angles that are congruent to one another. All right, well, opposite means they have to follow the diagonal. So H would be opposite of F. And I know that 140 are not equal. So that means angle G following this diagonal would have to be equal to angle E. So these two are equal. And let me put them as 3. There we go. Okay, that's good to know. I know. If I go back to the very first lesson, I know that I can find what these 4 angles, E, F, G, and H add up to. If I use the formula n, my number of sides, minus 2 times 180, right? This is going to give me what the 4 angles inside sum up to. So n is 4 minus 2, that's 2, times 180. These 4 angles have to add up to 360 degrees. So here's what I'm going to do. I'm going to take the 100 and I'm going to add to it the 40, which is 140. I'm going to take that and subtract it from the 360. Okay, so 360 minus 140 gives me 220 degrees. That's what's left for my 2 purple angles. Since there are 2 of them, I'm going to take this and divide it by 2, and that's going to give me what each one of these angles is equal to, 110 degrees. Okay? All right. The last question that they're asking is find HG. Oh, I'm missing stuff on my thing again. Here we go. 3, 3, 5. Yes, there we go. 3, 3, 5. There we go. Okay, so find HG. Let's grab a different color. Here we go. And let's highlight HG. 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 There it is. They want me to find this? I don't know, guys. Wait. I do know. There's a 90-degree angle right here at the perpendiculars. Then what I have, let me grab my highlighter. Let me change it to the pink. I have right here a right triangle where I know 2 of the 3 sides, which means I can use the Pythagorean theorem. I can say a squared plus b squared equals c squared. Remember, c is the most important one, and c is your hypotenuse. Remember, the hypotenuse cannot have the 90-degree at either end. So that means HG that they want you to find is your hypotenuse. So this is C, and then I'm going to make the 3's be A and B. So 3 squared plus 3 squared equals, I'm going to change the question mark to an X because we'd like to think of X as what anyways. Remember, 3 squared is 3 times 3, so that's 9 plus 9. They are together on the same side. Remember, you always want to look at your equal sign to see where your numbers are. Since your numbers are together on the same side, you're going to go ahead and add them. If they were on opposite sides, then you would subtract. 9 plus 9 is 18. And remember, the last step of the Pythagorean theorem is to take the square root of both sides. Now, the square root of 18 is not a perfect square because 18 is not a perfect square. That just means that you're not going to get a whole number answer. You're going to get a decimal. And when I put it in the calculator, it would round to about 4.2.